Good afternoon, everyone. Just going to give it a couple of seconds to let everyone get filtered in here, and then we'll get started for today. Alrighty, I see that number jumping up pretty quick, so let's get started. Good afternoon, everyone, and thank you for joining us today for the live webinar using AI-enhanced NIR technology to optimize feedback sorting. Before we get started, I just want to extend a big thank you to the Wood Pellet Association of Canada for sponsoring this webinar. I'm Alex Shoretsky, Digital Marketing Coordinator for WPAC, and I will be your moderator for this session. Before I pass it over to your speaker this morning, I'd like to take a moment to just go over a few housekeeping items. Firstly, this webinar is being recorded, so for any reason you have to leave early or you miss part of the presentation, a link to the recording will be emailed to all registrants shortly. Secondly, the audience is in listen-only mode, so cameras and microphones will be turned off for you. However, the chat and Q&A function are open to you, and we will be answering those questions after the presentation. Now I'd like to introduce your speaker for today, Dr. Fahimeh. Dr. Fahimeh has been engaged in research and discovery in the emerging area of bioenergy for over 15 years and has managed bioenergy projects for a variety of clients, including governments, manufacturers, and technology developers. She has led biofuel densification, pretreatment, and storage and handling research studies for 10 years, co-authored more than 80 technical reports and peer-reviewed publications in the field. Fahimeh, thank you so much for being here. I'd like to pass it over to you for your presentation.
Thanks very much, Alex, for the introduction. Good morning, good afternoon, good evening, wherever you are. Thanks for attending this webinar. I would like to take about 20-25 minutes to introduce our exciting AI-enhanced NIR project that we are trying to do for the wood pellet sector. So why NIR? Because the purpose really is to increase the use of forest and harvest residues that are being used by the pellet plants. And this method, which I will talk about in a second, is not only applicable to the pellet sector, but also any other sector that is using biomass for any other type of application. So I'd like to talk first about the challenges in the biomass sorting. So when it comes to biomass sorting, there are different challenges that exist. First of all, we have inconsistencies in feedstock quality. That's a big challenge. And one of them, for example, is the variation in moisture content. You might have biomass that has too much moisture, that requires extensive drying, or on the other hand, you might have biomass that is overly dried and may degrade. Particle size and having uniform particle size is another crucial factor. For example, if the biomass is intended for combustion, ideally, you're looking at uniform and smaller particles. But if your biomass is intended for example, biochemical processing, then you might need another type or another size of particle. So you see all these, like biomass is heterogeneous. So all of these variations create multiple challenges when you're sorting biomass. Composition is another one. So the chemical makeup of the material is different depending on what age the biomass is, how long has it been sitting in the rain, for example, what was the storage condition that it has been, the ash content, impurities, all of these are different for different types of biomass. And you can imagine we have all these different streams of biomass coming to the pellet plants, and you're going to have to blend this material and make high quality pellets that meet the standards, the ISO standards. Also, presence of contaminants is a challenge. So we're talking about both physical and chemical contaminants. We've got, of course, physical contaminants would be things like stones and rocks and things like that that can damage machinery. On the other hand, that you have chemical contaminants that could affect the balance, the chemical balance that is required for certain processes. So at the end, all of these inconsistencies will end up in the quality of the end product. So what are we proposing? Our proposal is actually centered around the use of NIR technology and coupling that with, coupling that with AI technology. So first, we want to develop a fast characterization method using NIR technology. So this method will allow us now to efficiently analyze the feedstock, make quick decisions, make informed decisions, and also be able to come up with an optimal blend for production of pellets. So really the goal here is to better understand our feedstock and be able to quickly decide on the optimal blend. Right now, what happens, you're doing kind of a trial and error, and you mix different streams of in-feed that is coming to the pellet plant, and you mix them and you try to utilize all of them. But we're trying to come up with a fast and quick method that the pellet plants can utilize every type of material that comes into the plant. And of course, utilizing all of those material to be able to make pellets that meet the ISO standard 17225-2 requirements. So as I mentioned, the aim is to investigate the application of NIR spectroscopy to rapidly homogenize all of these diverse biomass feedstock streams that are coming to the pellet plants. Now, if we can succeed in this project, we will be able to utilize any type of material that comes to the plant, including forest residues, burnt wood, reclaimed and recycled wood, and any other underutilized wood fiber, efficiently and economically. So let's take a closer look at what feedstock sorting and blending mean in a context of a pellet production. So the process starts, as you can see on the left, with raw biomass, and that can come from different sources, and we have showed it here. It's illustrated with different colors. So that could be agricultural material, it could be sawdust, it could be forest residues, it could be burnt wood, anything really. So each of these feedstock will have its own characteristics in terms of moisture, ash, chemical composition, mineral content, and all those kind of things. To make sure that we have optimal pellet production, the very first step would be sorting and grading this material. So we categorize this material based on its properties now. And the key properties that would be important for us is the moisture, the particle size, and the chemical composition. These three parameters are key in pellet production. So now this will allow us to separate these types of biomass to different types. For example, A and B and C, as you can see here. After we do sorting and grading, now we get to controlled blending. And that means it's critical because it allows us to combine all these different types of biomass and combine them and come up with a specific ratio and come up with the optimal blend. So for example, in that controlled blending, you might end up with 70% of A, 10% of B, and 20% of C, for example. So really, by carefully sorting and blending the biomass feedstock that is coming in, we can produce pellets that have high durability, that have better burning efficiency, and have consistent quality. And of course, maximize any type of underutilized material that is, or in-feed that is coming to the pellet plant. So what is near-infrared technology, and how are we going to use it in this project? So this NIR, many of you might know, it's something that has been around for so many years. So it involves the use of near-infrared light, which is part of the electromagnetic spectrum. It's just above the visible light range. When it interacts with the material, it causes the molecules to vibrate, and then that vibration can be measured and analyzed. So this makes NIR a very unique methodology or procedure because it's not an invasive procedure, and also it helps us to quickly come up with be able to detect the concentration of different substances, the moisture, particle size, and everything that is important for us, and make quick decisions. So in the biomass industry, it could play a significant role. Specifically, we are looking here in the context of this project for the pellet plants. So by analyzing the light that is reflected from the material, then we are able to understand the material better, and we can see what is the moisture, what is the particle size, what kind of chemical composition we're dealing with, and see how we can blend all these different streams. I would like to mention that NIR is particularly efficient in using moisture content, which is very, very critical in a pellet production. So as I mentioned, we are, as you can see here, we are shining the NIR light on the material to analyze the molecular composition. This analysis is based on how different wavelengths of the lights are absorbed or reflected or transmitted by the material. And each material, in a way, has its own distinctive NIR spectrum. So every type of material that you put in there will have a different spectrum coming reflected from it or transmitted or absorbed. It's kind of like a fingerprint, so it's really unique to the material. So that spectrum will help us to identify and quantify all these components that are present in that specific biomass. And to capture this data, now we use a spectrometer that collects the light from the material, and then the software uses complex algorithms to analyze this information and determine the concentration of specific substances. So now we are proposing to couple AI with NIR because we believe that one of the bottleneck that NIR hasn't been able, we haven't been able to use NIR with biomass. There are so many work has been done, but there is not a commercial calibration model or method for the use of NIR with biomass that has been successful. And the reason is that depending on the biomass size, particle size, moisture, chemical composition, and it's a heterogeneous material, and it's really hard to come up with an enhanced calibration model. And we believe that for this to be successful, you need thousands and thousands of data sets and properties of the material to feed into your calibration model. And to be able to do that, we need AI. So first of all, AI allows us to have improved data integration, because now we are able to produce and process large data sets and be able to make decisions, more insightful conclusions, and make decisions quickly using all these large data sets that are being processed. We can enhance, then it will allow us to have enhanced calibration models. I just talked about that. Now we are having thousands of data that can be processed, and now we can have an enhanced calibration model because it's not just a couple of data points and properties that we are feeding into the model. Real-time monitoring and decision making. So we are measuring all these properties of biomass in real time, and we are feeding the results back into the system. So this calibration model keeps correcting and optimizing itself in real time. And we keep feeding these results to the process to make adjustments to the blend that needs to be done, like the ratios and how the blend needs to be prepared for the pellet production. Pattern recognition and anomaly detection. So the system, it's AI powered. So the system can spot the trends in the large amount of data, and it can flag any unusual reading that you have. You won't be able to do that manually, because if you have thousands of data, it takes you months and months to analyze those data and be able to see if there is any red flags in there. But with AI, we are able to do that. And we can, of course, multivariate analysis. We can now do a multiple variables analysis at the same time, simultaneously. And we can adopt it to diverse applications. As I mentioned, this is not specifically to pellet production. You can use such a system, such a model, for any type of biomass applications, like whether it's going for SAF production, whether it's going to biochemical, biomaterial, anything. So you can have quick decision making, and the beauty of it is that this system keeps getting optimized, because all the data that you are reading goes back to the system to make it more and more robust. So just quickly, how does it look if we are, what does it look like if we are going to integrate such a system into a pellet plant? So of course, the very first step would be to have a complete assessment of your current operations. So you have to make sure you understand the existing equipment and processing and all the limitations you have at your pellet plants. We need to quantify and identify how the AI-enhanced system, NIR system, can complement or improve your existing system. Then you move on to a pilot testing and calibration. We will identify one plant, then we'll go to do the pilot testing to evaluate our system, and then it will help us to calibrate our system to the specific needs of that pellet plant. And then we'll go and look at the system integration with the existing equipment. This system will have specific requirements. We'll go and take a look at how does the integration look like with the existing equipment, what are the limitations, and so forth. It's a new system and new technology. So of course you will need training and onboarding. You will have to have your operators and staff trained. And then we will get to full scale implementation, and we can implement it at different pellet operations. Just like any other new technology, you're going to require performance monitoring and continuous optimization. You have to look at your system and see how it's running and keep doing performance monitoring, and scalability and expansion. What are the benefits of such a system for a pellet production facility or just any other bioenergy application? We kind of went through that, but I just want to highlight a few of them one more time. First and foremost, we have improved feedstock quality, and we talked about that. The quality will be consistent, and that's key to produce high quality pellets in this case. You have increased production efficiency because you're going to have less and less errors and reduced downtime in the plant and less cost. And of course, production efficiency will go higher. You're doing real-time monitoring and adjustment, which is very, very, very exciting. And that helps us to be able to detect any anomalies and be able to make quick decisions. You don't have to wait a couple weeks to analyze the properties and come back and fine-tune your operation. You can do these in real time. And of course, you have reduced waste and energy consumption, and enhanced predictive maintenance. You've got AI now, so you can predict what machinery is failing and make ahead of time, make decisions to be prepared for that. So you will have reduced downtime in your plant. And if you have such a system, then of course, higher market competitiveness and cost savings down the road. There are, just like any other technology, there are challenges and considerations that I have to talk about. So integration with the existing system is key. One of the first challenges is a smooth integration with the existing systems. It's a new technology, and for all of you that are involved in this sector, you know that introducing any technology comes with its own challenges. The initial investment and return of investment. So it's another key consideration is the return of investment and the initial investment you need to do. The system offers long-term benefits, but the upfront cost could be substantial. So understanding all of those and how quickly your investment will pay off is crucial in your decision making. Data management and processing. Now you've got AI in the system, so you are dealing with influx of thousands and thousands of data. So you have to make sure you have a data management and processing in place that can deal with that. Training and skill requirement. You need to have proper training in place for your staff. I don't want to call it complicated, but it's a new technology and coupled with AI. So you need proper training for your staff and operators. Ongoing maintenance and calibration is required, which is just like any other technology. And there would be resistance to change. And we're trying to start with one pellet plant, and we do know that there is always resistance to change. It might there is resistance from management, from operators to get out of the comfort zone and try this. It comes with its own risk, but if this project is successful, the impact is substantial. I would also like to take 2 minutes to talk about the fact that we have been working with different stakeholders, looking for funding and applying for different government and industry programs that are out there and are specifically aimed at such technologies. We are still seeking funding support to fully realize the potential of this really exciting project. If there is any of you that is interested to know more about this project, or you're willing to direct us to a program that we can look into and get this project fully funded, we would appreciate that. So I also want to mention that all of this work is impossible without our partnership with the Biomass and Bioenergy Research Group at the University of British Columbia. They are our R&D partner, and we are working closely with them on this project, not only on this project, but in many other projects as well. And just closing the webinar, but saying that the sky is the limit, really. So as we look ahead, it's clear that such technology and such things that are powered specifically by AI are coming and transforming the future of different industries, and it could do the same with the pellet production. I've talked about all of these, and I'm not going to go through that one more time, but as I mentioned, it could have a significant role in optimizing our pellet operations. Not only that, but also it could make a significant role in the bioenergy sector. So with that, I'd like to open it to questions if there are any questions. I hope I'm still on time. Yeah.
That was great. Thanks so much, Dr. Fahimeh.
Yeah.
A bunch of questions rolling in, so let's just jump right in here. The first one that I'm seeing is, can we use the AI-enhanced NIR to measure the carbohydrates such as, and I'm sorry, I'm going to butcher these, hemicellulose and
And
cellulose?
cellulose.
Yeah.
Yes, of course. And that's one of the key parameters that is very important for us, the chemical composition. And yes, you can do that. It's just challenging because as I mentioned, when the particle size changes, the moisture changes, and the age of the material changes, it's just challenging. But yes, it's able to do that. And we are intending the model to be able to measure all of these properties, but we're probably not able to start with all of them. We'll probably start with moisture at the very beginning and keep feeding data sets into the model to make it more and more powerful. But to answer your question, yes.
Awesome. Thank you so much.
Mm-hmm.
Got a two-parter here. Will the deck be available later? We're sending out a recording for everyone of this webinar. And then the second part of that is, can you apply this technology to both fuel and food pellets?
Yes, you can apply this. NIR has been around for so many years. And if you look up, there has been so many works done in this area for different material, including food and agricultural material, any other type of material. But the problem with the biomass is that it's heterogeneous, and there has been a number of studies out there, and there is so many work done, but it's limited. The scope is limited. We're not somewhere that we can have a robust method that we can make quick decisions. The scope of the work, all of the work that has been done is very limited. And then when we looked at all of the previous work done, we realized that the bottleneck is just the calibration. And it comes with, and the issue comes with the heterogeneity of the material. So that's why we introduced the AI into and coupled it with NIR, which we think can resolve the issue. And with that amount of data sets that we are able to process in seconds, we are able to make that that calibration really, really robust.
Awesome. Thank you. Got another one here. It's a bit of a longer one, two-parter, so bear with me. Are you able to share any metrics around the accuracy of the NIR measurements? For example, what error exists on moisture content measurements? And then they go on to say, also for the blend optimization, is that based on an in-house model, AI capabilities, or is that based on some site-specific data and modeling that needs to be done after accessing the data?
Okay. So for the first one, I don't have those numbers off the top of my head, but we can chat offline on these specific numbers in terms of errors and stuff. But again, just to put it in context, it's different depending on what type of material you're using it. And as I said, if you look at 20 studies, you will have many different, like the error that you're reading is different because the model essentially is not optimized for use with biomass yet. But the second one, it's when we are doing this optimization, the blend optimization, it depends on, it's site specific because it depends on what type of material that site has access to. Is it hog fuel? Is it sawdust? Is it what kind of, is it bark material? Do you have high ash content? So it will be site specific, but once you have that blend, and that blend is ever changing. So the plant will be able to feed in whatever they have on site, and all of these have a specific cost. So some of them are lower cost, some of them are really expensive in feed. So then they will be able to put all these variables or parameters in there, and based on the maximum utilization of all of the resources and bringing down the cost, they can decide. So it's not one size fit all model. So it will be site specific. I hope I answered that question.
Yeah, no, that was great. Thank you. Got another one here, and it's asking, can this technology be used as a mobile tool that can be used by an operator at the source of biomass supply rather than at a pellet plant?
That would be the aim, Mahmoud, and but we're not there yet. But once the model is robust and is we have that and it's finalized, then having it on a cell phone will be ideal. But you have to keep into mind that it's like the NIR will be an equipment that will be on the site. So even though if it's on your mobile, we're not there yet, but essentially you might have to be at the plant to be able to do all those adjustments and everything. You can't you can make changes to the plant recipe or things like that when you are offsite. But down the road, these will come. But for now, we are just focusing on having that model and run it at one pellet plant.
Perfect. Awesome. Looks like we got time for about one more here.
Sure.
So one that I'm seeing is, can generative AI be used to generate more data points from experimental data, then apply them to prediction modeling?
Generative AI can be used, well, possibly, but what I would like to do with this model, because through the partnership with the Biomass and Bioenergy Research Group, we have thousands of data for specific biomass that we have collected over the past 15 years. And because we've measured the properties of those biomass ourselves, and we do trust all of those, we'd like to start off with those data sets as in-feed for the AI part and keep introducing to them. But I think we will have enough data sets to start with, but down the road, we might need more and more data, which the thing is, when you are introducing those data, you have to know all of the parameters. What was the particle size of that feedstock or biomass that the property was measured? What was the moisture and everything? And it's, if those are AI generated, I don't know if I can I can use those data to feed it into the AI. So we have tons of data that we've produced ourselves, and we will be using those for the calibration as a starting point. But remember, once you have the pilot going and you keep measuring data, or anything you read at the plant, which on daily basis, you will read many data points. All of these will be fed back into the model, and it will keep using those and fine-tuning or optimizing itself.
Awesome. Well, thank you so much, Dr. Fahimeh. That was a very informative presentation. Really appreciate that. Unfortunately, that is all the time that we have for the webinar today. I just wanted to once again extend a thank you to the Wood Pellet Association of Canada for sponsoring this webinar. Also, just wanted to extend another thank you to Dr. Fahimeh once again for being here today to give this presentation. Finally, I just want to extend a big thank you to the audience for your questions and participation. Watch your inboxes for a link to the recording and any answers to your questions from today's session. Thanks, everyone. I hope you have a great and safe day.
Thank you, everyone.
Thank you.